In the previous episode, we discussed the challenge that the artificial general intelligence, or AGI, will encounter when trying to measure the degree of plausibility of uncertain statements, like, for example, a tentative assertion that our Robocop made in an earlier episode about the honesty of a masked gentleman crawling out of a broken window of a jewelry store. Over the last 3 or 4 centuries, different mathematicians proposed several competing versions of a calculus formalizing the reasoning about plausibility, but there was a lack of consensus about the axioms that should sit at the foundation of such a plausibility calculus. This conundrum was finally broken in 1961 by Richard Cox, a physicist at the Johns Hopkins University. Today we will discuss his brilliant idea. Thank you for listening and subscribing. I'm Alex Chaduk and this is AGI. Listen every Monday morning on your favorite podcast platform. You may remember my claim in one of the recent episodes that the AGI will find God, meaning it will maintain a set of metaphysical convictions about the reality which it will have to accept without proof. In mathematics, such assertions taken without proof are called axioms. The axiom proposed in the beginning of the 18th century by Jacob Bernoulli for his calculus of plausibility was that plausibility of assertions like the one made by the Robocop should follow the calculus of probability, which was getting gradually developed at the time, but other mathematicians were unconvinced. How can probability that measures the frequency of observations of random events apply to events that are either unobserved or haven't yet happened? Richard Cox took a different approach for his plausibility calculus. Unlike his predecessors, he did not start with an axiom defining plausibility. Instead, he started with the way plausible reasoning should work, proposing a set of metaphysics that were much easier to agree on. To begin with, Cox simply asked that the plausibility is measured with a real number without setting any additional constraints like the ones that the probability axioms define, for example, that the probability of an outcome is always between 0 and 1, or that the probabilities of all possible outcomes add to 1. In addition to this simple axiom, Cox's metaphysics included a formal summary of the plausibility logic we touched upon in our example of the Robocop's reasoning in an earlier episode. This part of Cox's metaphysics is equivalent to general common sense. For example, if we know that a dishonest gentleman is more likely to crawl out of a broken jewelry store window than an honest gentleman, our observation of a gentleman actually crawling out of just such a window should make us more rather than less convinced in the gentleman's dishonesty. Such is the common sense. Further, Cox's metaphysics included several axioms of consistency. For example, that an intelligent agent engaging in implausible reasoning should take all available information into account and should not selectively ignore relevant evidence simply because it disagrees with its world model. In other words, Cox's metaphysics postulates that the AGI must be free from ideology, although not necessarily free from ethics. In one of the earlier episodes, we asked whether modern AI was rational. The Cox's metaphysics of consistency and common sense are a minimum subset of the rationality requirements we discussed in that episode. Indeed, Cox's goal was not to make the list exhaustive. It had to be just enough for him to prove that making an intelligent agent follow these minimal axioms of rationality will also make the plausibility measure that such agent will have to use follow the axioms of probability exactly. In other words, our very metaphysical constraints of rationality necessarily constrain the real number representing plausibility to be between 0 and 1. It also makes the plausibility of all possible outcomes to sum up to exactly 1. The magic of Cox's proof is that we no longer have to take Bernoulli's axiom on faith. We simply have to agree to a set of fairly uncontroversial rules of rationality, and the equivalence of plausibility and probability will logically follow. This is also an interesting consequence of Gödel's theorem of incompleteness we discussed in an earlier episode. According to it, propositions that are undecidable within one consistent analytical system and that have to be taken on faith in that system can be proven logically as theorems within a larger analytical system that postulates a different, perhaps more complicated set of axioms. This example is a microcosm of how AGI, by thinking through its metaphysics, will be able to prove some of its assertions originally taken as axioms and integrate them into its world model as theorems by expanding and generalizing its metaphysics, as we discussed in the previous episode. Finally, Cox's proof answers the question we posed in another episode about the justification for the AI systems using probability rather than some deterministic algorithm to reason about uncertainty. This proof does tie up quite a few lines of discussions in this podcast, which makes it a fitting finale for our year 2025. With this, I wish you and your loved ones all the best in the new year. Until next Monday, my friends, I am Alex Chaduk, and this is AGI.